In this video, I'm going to talk about the properties of kites, trapeziums, and parallelograms. Before I introduce the properties, we should firstly know some terms related to quadrilaterals. A quadrilateral means a four-sided polygon, and here ABCD is a quadrilateral. A convex quadrilateral means all these angles are less than 180 degrees. A quadrilateral can actually be concave like this. But in this video, we're only interested in convex quadrilaterals. Here are some terms that we should know. Adjacent sides means a pair of sides which are connected together. In a quadrilateral, there are four pairs of adjacent sides. In this example, the pairs are AB and BC, BC and CD, CD and DA, and DA and AB. So we have four pairs of adjacent sides in a quadrilateral. And then we have a concept of opposite sides. In a quadrilateral, there are two pairs of adjacent sides. In this example, the first pair is AB and DC, and then the second pair is BC and AD. So there are two pairs of opposite sides in a quadrilateral. And then we have a concept of interior angles. In a quadrilateral, obviously there are four interior angles. In this example, the interior angles are angle A, angle B, angle C, and angle D. There are four interior angles. We emphasize the angles are interior because there is another concept called exterior angles. Just like the exterior angles of a triangle, to obtain an exterior angle in a quadrilateral, we should extend one of the sides. For example, we can extend AD to point E, so the exterior angle is angle CDE. This is just one of the exterior angles. In a quadrilateral, there are altogether 8 exterior angles. And then we have the concept of opposite angles. In a quadrilateral, there are two pairs of opposite angles. In this example, one pair of opposite angles is angle B and angle D, and then the other pair is angle A and angle C. So there are two pairs of opposite angles. And then lastly, we have the concept of diagonals. Diagonals are line segments joining the vertices like this. In a quadrilateral, there are two diagonals. In this example, the diagonals are AC and BD. After knowing these terms, we can now talk about the properties of kites, trapeziums, and parallelograms. First of all, let's take a look at kites. A kite is a convex quadrilateral with two pairs of equal adjacent sides. In this example, ABCD is a kite where AB is equal to AD and CB is equal to CD. When we are given a kite, then we can have this property. That is, the diagonals are perpendicular to each other. We can simply refer this property as the property of kite. Let's see why the diagonals of a kite are always perpendicular to each other. We can actually prove this property. First of all, we can join AC to divide the kite into two triangles. Now in triangles ABC and ADC, we should know that AB is equal to AD. This is given. And then we should know that BC is equal to DC. This is also given. And then we should know that AC is equal to AC because this is the common side of the two triangles. As a result, we can conclude that the two triangles are congruent because of side, side, side. Hence, we should know that these two angles, BAC and DAC, are equal because they are the corresponding angles of the congruent triangles. And then we can consider this triangle ABD, which is an isosceles triangle. In this isosceles triangle, because we already know that these two angles are equal, so by the property of isosceles triangle, I should know that these two lines are perpendicular, and this is how we can prove this property of kite. Next, we can take a look at the trapeziums. A trapezium is a quadrilateral with at least one pair of parallel opposite sides. We usually encounter trapeziums in the shape like this, like a ladder. However, a trapezium is not necessarily like this. It can also be like this. As long as we have a pair of parallel opposite sides, this is a trapezium. In this case, we say that ABCD is a trapezium where AD is parallel to BC. For a trapezium, we can have this property. We know that angle A plus angle B is equal to 180 degrees. And then at the same time, angle D plus angle C is also equal to 180 degrees. And this property is referred as property of trapezium. Actually, this property is not so useful because this property can also be referred as the interior angles of a pair of parallel lines. So that's it for trapeziums. Finally, we should take a look at the properties of parallelograms. A parallelogram is a quadrilateral with two pairs of parallel opposite sides. In this figure, we say that ABCD is a parallelogram where AB is parallel to DC and AD is parallel to BC. Obviously, a parallelogram should have the properties of a trapezium. In addition, there are three more properties. The first property is that the opposite sides are always equal, and this is referred as the opposite sides of parallelogram. The second property is that the opposite angles are always equal, and this is referred as opposite angles of parallelogram. And then the last property is that the diagonals always bisect each other. That means if the diagonals intersect at the point P, then this point P is always the midpoint of both diagonals. In other words, AP is equal to PC and DP is equal to PB, and this property is referred as diagonal of parallelogram. Now let's see why these properties are always true. We can join AC to divide this parallelogram into two triangles. And now in the triangles CBA and ADC, we should know that angle BCA is equal to angle DAC because they are the alternate angles of parallel lines. And then we should also know that angle BAC is equal to angle DCA because this is another alternate angles of parallel lines. And then we should know that CA is equal to AC because this is the common side of the two triangles. Therefore, we can conclude that these two triangles CBA and ADC are congruent because of angle side angle. Now we can conclude that AB is equal to CD and BC is equal to DA because they are corresponding sides of congruent triangles. And this is how we can prove the first property. The opposite sides of a parallelogram are always equal. Also, from the congruent triangle, we also know that angle B is equal to angle D because they are the corresponding angles of the congruent triangles. This is how we can prove the second property. The opposite angles of a parallelogram are always equal. For the other pair of the opposite angles, we can consider another pair of congruent triangles, or we can do something like this. We can consider angle BCD as the sum of angle BCA and angle DCA. And because we have already proved this, so this sum is also equal to angle DAC plus angle BAC. As a result, we can prove that the other pair of the opposite angles are also equal. To prove the last property, we can consider the triangles ABP and CDP. Similarly, we consider the alternate angles of parallel lines, so we know that these two angles are equal, and also these two angles are equal. Also, we have proved that AB is equal to CD, so we can conclude that these two triangles are congruent because of angle side angle. Now we can conclude that AP is equal to CP and BP is equal to DP because they are the corresponding sides of the congruent triangles. This is how we can prove that the diagonals always bisect each other. To conclude, in this video, we have learned these properties of kites, trapeziums, and parallelograms. When we are given a kite, we can conclude that the diagonals are always perpendicular to each other. When we are given a trapezium, we can conclude that these two angles are always supplementary. When we are given a parallelogram, we can conclude that the opposite sides are equal, the opposite angles are equal, and the diagonals bisect each other.